Everybody, this is Miss Piekarski. I'm going over the getting ready problems from page 278 in your textbook. And I noticed that a lot of my students, they're okay with the pre-cal stuff and the trig stuff, but they're really struggling with the algebra behind a lot of the things that we're going to be doing. A lot of things that we have done and some of the things we're going to be doing. So I'm going to go ahead and do the video on these problems. You will need to turn in your work for this, and I'm going over all the problems in the textbook or on this page. You will, of course, need a separate sheet of paper to show all your work, and you're not going to get credit if all you have is the answers. So let's go ahead and get started with the problems. The first one, you need to factor each of the following completely. So you have 6 times x to the 4th power minus 12 times x to the 3rd power plus 3 times x squared. So one of the things that you need to figure out is what the greatest common multiplier is, or greatest common factor is between all these. And if you look at all three of these factors, all three of them are the numbers here, the 6, 12, and 3 are all divisible by 3. So you can factor out a 3, and all of them have at least an x squared. So we're going to factor out 3 times x squared from each one of these terms. Okay, so when we do that, we have 3x squared on the outside, and then in parentheses we're going to have what's left of everything else. So 6 divided by 3 is going to be 2, and then x to the 4th power divided by x squared is going to leave you with x squared. Okay, and then the negative 12 divided by 3 will give you a minus 4. And then x cubed divided by x squared is just x. So when you're dividing your terms like this, where you have x to the 3rd power divided by x squared to the 2nd power, realize that all you're doing is subtracting the exponent here from the exponent up here. So it's just going to be, you're left with an x. And then here your 3 times x squared divided by 3 times x squared just gives you 1. So once you factor everything completely, that is what your answer looks like. Okay. Another problem, this one, you have 49 times x to the 4th power minus 36 times y to the 4th power. And again, we're factoring completely. Hopefully you guys have noticed that this 49 can also be written as 7 squared, and then x to the 4th power can be written as x squared and then squared again, and then minus the 36 is 6 squared, and then the y squared is just y squared. Okay, so what you end up having is a difference of squares here. Okay, so we're just going to factor it like we would a regular trinomial. Okay, and of course, because we have a minus sign, with most polynomials, you'll have like you'll have one term, like maybe some number x squared, and then minus, or you might get a plus, some middle term here. You might have like a 2x, and then a minus or a plus some number. Okay, so you have your first term, your and last term, and then the middle term. Well, notice this just has 2 terms. Your middle terms ends up getting canceled out. So one of these factors will have a minus sign in the middle, and one of them will have a plus sign in the middle. Okay, so I'm going to show you both factors. And then, and in order to have the middle term completely cancel out, all the numbers, this number has to match this number, and this number has to match this number. And what the difference is one you're subtracting and one you're adding. Okay, you should have gone over problems like this towards the end of Algebra 1. Hopefully you went through them, and then in Algebra 2 you went through problems like this. Okay, so it's just the differences squared or something, I think is what it's called. All right, anyway, so realize you have 7 squared here. So you're going to have 7 times x squared here, and you're going to also have 7 times x squared here. Now notice the x squared is on the inside squared, so both of these terms will have x squared, but both of them, instead of having 7 squared here and 7 squared here, you just have 7. Okay, and then here, oh, you know what, I forgot to write the y squared. Let me write that down really quickly. This was times, that's supposed to be a y squared. Oh my goodness, my mouse is not working. There we go. All right, so let's work on the last half. Because each of these are squared, then you're just going to be left with a 6y here and a 6y here. So you notice that all your numbers and your variables match exactly. The only difference is one factor is plus and one factor is minus and one factor is plus. And honestly, it doesn't matter which order you have those in. All right, another problem. Factor each of the following completely. This time you have 8, a 2, and a 15. Those terms will not be divisible very well. A couple ways that you can do this. You can ask yourself, okay, what numbers multiply together to get 15? And we have a negative here. So again, one of our factors will have a plus sign and one will have a minus sign, but we're not sure which ones will be which. Okay, so let's look at our number 15 and see what combinations will get us a 15. So if you had a 1 times 15, you get 15. If you had 3 times 5, you get 15. And that's it. Okay. Now, one of these numbers is going to be negative and one is going to be positive, but we're not sure which one. We also have to deal with this 8 here. So the 8, this was to get 15. Now to get 8, we can have a 1 times 8. We can have a 2 times 4. I think that's it, right? 1 times 8 and then 2 times 4, right? All right. Now on this, both of these are going to be positive because you have a positive number here. Here you're going to have one negative value and one positive value. So we need to do a lot of different experimenting to see what type of combination will give us a -2 here when we're adding the two terms. Okay, so one of these numbers here will get multiplied. One of these numbers here will get multiplied by one of these numbers here. And so one here will get multiplied by something over here, and then one number here will get multiplied by something over here. And then we're going to add everything up and get a -2. So if we multiply, if 1 is a positive number, then we can multiply it by 1, by 2, by 8, or by 4 and get a positive number. Okay, if 15 is a negative number, then 1 would have to be, so if 1 is our positive number, then 15 would have to be our negative number. So let's say we had 8 was positive and, 1 was positive and we multiplied 1 times 8. We just got an 8, and then a -15 times 1 gives us -15. Well, -15 plus 8 does not give us -2, so that combination won't work. If you tried it with the 2 and the 4, it's also not going to work there. So most likely this combination is not going to be used at all. Okay, now let's look at the 3 and the 5. If we had a -3 times 8, that would give us, what, 24, and then a -5 would not work. Okay, if we had 5 times 8, that would be 40. That's not going to get us anything close to 2. So most likely that combination right there is also not going to work. If we had 3 times 2, that would give us 6. And if we had 5 times 4, that would give us 20. That's not going to give us anywhere close to 2. What if we had 5 times 2 gives us 10, and 3 times 4 will give us 12. So if we had 3 times 4, that gives us 12. And then we would have 5 times 2. Oops. There we go. Would give us 10. And then we're going to add or subtract these. Now remember, we want to get a -2, so our bigger number needs to be negative. So we're going to make that negative. 4 and 2 have to be positive, so we're going to end up with a -3 here and a +5. So that's how we're figuring out our factors. So 5 has to be multiplied by 2, and 3 has to be multiplied by 4. Okay? So in your factors, your 3 is going to be negative, so we're going to have the -3 here, which means our 5 is positive, so we're going to put our 5 here. Whatever number we put up here is going to be multiplied by the -3. Well, we're multiplying 4 by -3, so we're going to have a 4x here. And then 5 is going to get multiplied by our number 2 here. So this is what our factors end up being. Okay. I know I kind of breezed over several different steps and everything that you probably learned in Algebra 2. If you remember better on how your teacher taught you in Algebra 2 or Algebra 1, great. But I do need you guys to remember how to factor these problems. They can be a real pain in the butt, and there are some shortcuts, and hopefully you will be able to remember how to factor. All right, another example, we are going to simplify each of the following rational expressions. Okay, and anytime you're simplifying rational expressions, there's usually more than one way or more than one method to follow. Just in this one, I know I need to add these two factors together, or fractions together, and before you can add fractions, you have to have common denominators, okay? And I notice here that all 3 of these terms can be reduced. You can factor out a 2. So the 12 divided by 2x plus 6, I am just going to divide every single one of those numbers by 2. So 12 becomes a 6. 2x divided by 2 just becomes x, and then 6 divided by 2 becomes 3. So this here is going to get replaced with 6 over x plus 3. Okay? So now I'm going to add those two fractions together because now my denominators match. This denominator matches this denominator. So in the numerator, I'm going to have 2, whoops, let me fix that. I'm going to have a 2x from right here plus 6. Oh my gosh, this is a pain in the butt to use this mouse. All right, plus 6. That's a 6. And then in the denominator, I'm going to have an x plus 3. Okay. If you look in the numerator, you have a 2x and you have a 6. You can actually factor out a 2 between those. So your numerator can become 2 times x plus 3. It's supposed to be a 3. There we go. And then you still have x plus 3 in the denominator. Okay, notice you have the same factor, x plus 3 divided by x plus 3. In the numerator and denominators, both of those factor out, and you're left with a 2. Okay, now I'm going to show you what the textbook had you, or how the textbook had you simplify it. So this one, they got you a common denominator by multiplying everything here by 2, then combining, and then you factored out what could be factored out. The x plus 6 ends up getting factored out, and you're left with 4 over 2, and then your final answer is 2. Notice, either way, you got it ended up with a 2 here or a 2 here. Either way, you get the same answer. Okay, a lot of these, there's more than one way to solve it. Okay, this example, we're still simplifying rational functions. This time you have 3 terms that, or 3 fractions you have to combine. and each one of them is slightly different. In order to add and subtract these, you have to have common denominators. So our common denominator is going to end up being a squared times b squared. Okay? And so with each one of these fractions, we need to do something to get a squared times b. Now this one is missing an a, so we're going to multiply both the numerator and the denominator by a so we can have a squared. Okay, so 3 times a is just going to be 3 times a. Okay, this one here, you have an a squared, but you need b squared. So we're going to multiply both the numerator and the denominator by b. So the numerator just becomes 2 times b. And then my last fraction, I have a squared and I have b squared, so I don't have to multiply anything there, and we're just left with minus 1 on the bottom. Now, some of you might try to factor more out here or combine like terms. There's nothing you can combine. So your answer is just going to be this. Okay? You can't simplify it any further. All right, let's look at another one. We have a fraction and a fraction, and we have to simplify everything that we can. Okay? We're going to focus on the numerator first, and then we'll look at the denominator. Okay, I want this to be one fraction here. So I need to multiply this y by y over y so that I get a common denominator of y here. So in my numerator, I'm going to end up with a y in the denominator, and then in the numerator I have x squared minus y squared. Okay, I get the y squared from y times y. All right, so that's my numerator. Now the denominator, I have 1 here, and I need to have y over y. So I'm going to multiply the 1 by y, I'm going to multiply, and I'm going to divide by y. So in the denominator, I'm going to have x minus y over y. Okay, so now you have better fractions and fractions, and we have to do the whole keep, flip, change thing. I'm going to shorten this. Oops, that's not what I wanted to do. I want to make it white, get bigger. All right, I'm going to shorten this so I have a little bit more space. All right, so we're going to do the whole keep, flip, change, and I'm getting random lines everywhere. Okay, remember KFC, I know you guys remember it. We've gone over it tons of times in class. I will work it out in the video again, but I'm never going to go over this in class again. All right, so the numerator, we're keeping the numerator exactly the way it is. We're going to have x squared. You know what? I am going to go ahead and factor my numerator. Sorry. So in this numerator here, the x squared minus y squared, that again is a difference of squares. It's x minus y times x plus y. And then in my denominator, I'm going to just have y. So that's the keeping. We're keeping this the same. Okay, yes, I know that I factored this top up here, but I didn't flip it or anything else. Okay, then I'm going to flip this. I'm going to have a y up here, and I'm going to have an x minus y in the denominator. Okay, there we go. And then we're changing the division to a multiplication. Now I'm going to start canceling things out. This y is going to cancel out this y. This x minus y here is going to cancel out this x minus y here. So the only thing we are left with is x plus y. Okay, that's the final answer. This one, it's super crazy, reduces quite a bit to just a very simple x plus y. All right, next we have, again, a fraction and a fraction. I know it doesn't look like you have a fraction and a fraction, but you do. You have this division line here. And this, you can factor lots of stuff out. So let's do the whole keep, flip, change thing and factor out as we go. So right here in my numerator, I'm going to factor out an x. So I have an x, and then in parentheses, I would have x plus 5 here. And then so this changes to this, okay? And then my denominator here, I'm going to factor that out. And I need two numbers multiplied together to get 5. If I do 1 times 5, I get 5. And then 1x plus 5x gives me 6x. So one of my factors is going to be x plus 5. Sorry, that was my dog barking. My other factor is going to be x plus 1. All right. And that is from here. All right, now this part here, notice the division sign, that's going to change to a multiplication when I flip the numerator and the denominator. Okay, so in this, the 3x plus 3, I can factor out a 3. And then I am left with x plus 1 there. And that's from this up here. And then this x cubed, I can factor out an x. Okay, and I'm left with x times x times x. I could write it as x squared, and at the end, we'll end up reducing it to that. But for now, I'm just doing it x times x times x. All right. So let's start canceling out what can be canceled out. So the x plus 5 here cancels out this x plus 5. This x here cancels out one of these x's. Then the x plus 1 here cancels out this x plus 1. So in the end, we're left with a 3 in the numerator and an x times x, or x squared, in the denominator. Okay? Let's look. Yep, there we go. On to another problem, finally. Problems 1 and 2 had lots of problems just because it was so long. All right. With problem 3, we need to draw a triangle. You know what? I'm not going to draw this triangle. I am actually going to use lines here. And we'll make them, yeah. So I have a ladder. It's leaning up against a building. I have no idea how long, let's see. So there's my ladder. And I know that the ladder is 32 feet long. That's 32 feet there. It's leaning against the building. This is my building here, and it's making a 75-degree angle with the ground. So that means that from here to the ground is 75 degrees. Okay? And then we want to know how high above the ground is the top of the ladder. So if this is the ground here, and this is going to end up being a right angle, that's the ground here, and we want to know how high it is here. So basically, I'm looking for this height measurement here. I am not going to use an H. I'm going to use a opposite because of my trig ratios. Okay, I want to know the opposite side to this angle. And you have a right angle here, and this ends up being the hypotenuse. Okay, so the trig function you need to use for this one is the sine trig function. So sine of 75 degrees. I'm trying to do a 75 there. 7 and a 5. There we go. Equals the opposite side divided by the hypotenuse. That's from my trig ratios, guys. I know you know this. And my hypotenuse is 32. So now to find the opposite side, this O, I'm going to multiply both sides by 32. And this, I would put my calculator in degree mode, and I would just type in 32 times sine 75 degrees, and we would push enter. And when I do that, the calculator will tell me that the opposite side is 30.9 feet. Okay? Hopefully this was a pretty simple one to understand. Let's move on to this one. So we have tell 4 measures of angle beta such that cosine beta equals the absolute value of 1/2. So that means they don't care if on the trig function you get a negative 1/2 or a positive 1/2. Okay, so hopefully you guys remember how to use your trig table. And notice they don't say whether to use your radians or degrees, and I will tell you that on the answer choices, they're using degrees. Here's one of the possible answers you could come up with. Okay, so we have cosine, and we're looking for either negative or positive 1/2. So we have a 1/2 here in the cosine column, which is 60 degrees. Keep on going down, you have a negative 1/2 here at 120 degrees. You can keep on going down, another negative 1/2 at 240 degrees, and then a 1/2 here at 300 degrees. So if we look, these are just sample answers. Those are the ones that you get from your trig table. Now, are there more? Yes, of course. You can do negative angles, positive angles. You could do radians. There's an infinite possible solutions with that one. All right, next question. Sketch two angles alpha such that tangent alpha equals -1. Now, for this, you need to remember that the tangent ratio is your y over x, okay, and we want to have our answer to be -1, so I need either y or x to be negative, but I need the numbers to be exactly the same. If you look on your trig table, or excuse me, not the trig table, but the unit circle, you can see that you have x's and y's here and here that are the same, and one is negative, one's positive. So this angle here would work to get that. Or you can have, again, this one here, you have the same numbers, one's negative, one's positive. So you could also have this angle here, and there you go. Those would be two angles. Or you could also have a negative angle here and have that answer, or a negative angle this way and get those answers. Those are all coterminal angles. All right, hopefully you remember how to use your unit circle. Trig ratios, this one I'm just going to end up showing the answers. Use your right angles for triangle ABC and DEF for items 6 and 7. For item 6, we just want to know the following trig ratios. So sine for A ends up being, so sine of angle A would be opposite over hypotenuse, so A over C. There we go. Sine or cosine for A would be adjacent over hypotenuse, so B over C. And then tangent for A would be, let's see, this is A, it would be opposite over adjacent, right? So it would be A over B. Whoops. You got to cover up the answer for D. So tangent A is A divided by B. And then you have all your reciprocals. Your cotangent A, cosecant A, and secant A will be the reciprocals of your other functions. So sine A is the reciprocal. Oh my gosh, I cannot believe the textbook did another problem or had another typo. All right, so it looks like they have the answer for cosecant is here. Okay, so the reciprocal of sine A would be cosecant A. Notice how my fractions are flipped. The reciprocal of cosine is secant. And again, notice how your fractions are flipped. And then the reciprocal of cotangent and tangent have flipped fractions. All right, problem 7. Find the measure of the following angles to the nearest tenth of a degree. So you would have your calculator in degree mode, and we want angle E. And so I know my opposite and I know my adjacent. I do not know the hypotenuse. There are a couple things you could do. First, you can find the hypotenuse, and then you can use any of your trig functions or trig ratios, or because you have the opposite and the adjacent, you can, because you have the opposite and the adjacent, you could just use inverse tangent. Okay, let me see if they work out the problems or just give you the answer. No, they just give you the answers. So I'll show you how to set up the problems, and then I'll show you the answers. So for E, you're going to do inverse tangent of the opposite side, which is 23, divided by the adjacent side, which is 16. Okay, and you would plug that in the calculator and you get an answer. And then, so for 7a, the measurement of the angle is, your calculator would end up giving you 55.2 degrees. For F, you would set it up. F, the opposite side is 16 and the adjacent is 23. So it'd still be inverse tangent, but it would be 16 divided by 23. And then your B value is 34.8 for angle F. All right, just a few more problems. Actually, I think this is the last one. It is. We want to write an equation for the graph below. Okay, so this can either be a sine or a cosine graph. Because the center of my graph goes through the origin, I'm going to make this a sine function. Okay, that way my C value is just 0, and I don't have to do x plus 0. Okay, I can just leave it as x. I do need to find my B value, and so I'm going to start here, I'm going to go up, I'm going to go down, and I'm going to go back here. So my period length is just 2 pi. So to find my B value, it would equal my 2 pi divided by my period length, which is also 2 pi. So that reduces to 1. When that's the case, then your then you don't have to write x times 1 or 1 times x. It would just end up being sine times x here. And because my sinusoidal line is at the x-axis, my D value would be 0. So I don't need to do a plus 0 at the end. Now I just need to figure out my A value. And the distance from my sinusoid to the minimum is 2 units. And then from the sinusoid to the maximum is also 2 units. So that just means my A value is 2. So the formula would be y equals, or f of x equals, 2 times sine x. All right, I know this was a pretty long video. Hopefully you understand most of this and were able to do most of this on your own. If you still don't understand anything, you might want to go back to your Algebra 1 teacher and say, please reteach me how to factor polynomials, okay? I will see you in class tomorrow. Hopefully you have all this done. Goodbye.